हेलो स्टूडेंट्स, सो कैसे हैं आप सब लोग? काफ़ी दिनों आपसे मिलने से। सो इन दिस वीडियो वी आर गोइंग टू लुक एट हाउ टू स्टडी फ्लूइड मैकेनिक्स फॉर गेट एग्जामिनेशन। ओके, विद फ्लूइड मैकेनिक्स बहुत सारे ब्रांचेस में एक कंपलसरी सब्जेक्ट है। सो इस वीडियो में मैं आपको फ्लूइड मैकेनिक्स का हर इंपॉर्टेंट डिटेलिंग मैं आपको देता हूँ, ठीक है। सो फर्स्ट ऑफ ऑल, बिफोर स्टडिंग एनी सब्जेक्ट लाइक फ्लूइड मैकेनिक्स और नॉट इवन इन फ्लूइड, एनी सब्जेक्ट इन जनरल, फर्स्ट ऑफ ऑल यू शुड नो वाई द हेल यू शुड स्टडी द सब्जेक्ट्स, राइट? बिकॉज ऑलरेडी लाइफ बहुत टफ है, क्योंकि हम इंजीनियरिंग मैथ्स पढ़ाते हैं, okay, and we do a lot of other subjects as well. So again, why one other subject? Okay, and you see this guy is not actually looking at me. I am not the fielder who dropped the catch. He is looking at that equations. Okay, and आप सबको पता है कि ये हमारा बहुत वावस्टिक इक्वेशन एक्चुअली ऑफ फ्लूइड मैकेनिक्स, नेवियर-स्टोक्स इक्वेशन। एंड जो फ्लूइड मैकेनिक्स हम पढ़ते हैं, सो सब चीज इस इक्वेशन में आता है एक्चुअली। ओके, सो दिस इज द नेवियर-स्टोक्स फेमस नेवियर-स्टोक्स इक्वेशन एंड दिस इज द कंटिन्यूटी इक्वेशन फॉर इनकम्प्रेसिबल फ्लो ऑफ course. Okay, so right now don't worry about these equations. Okay, I cannot hide. I think I am a bit thin. Okay, fine, I cannot hide, but right now don't focus on this. So why you should study fluid mechanics is, in general, this is one of the very fundamental subjects. Like for example, you see, you need not to be an engineer to understand all this stuff, that ice floats on water. And also, if you understand one thing here, whenever you start filling water from the tap, normally as a person, if you see, water comes out, fills the glass. But if you understand a bit deeper, the cross section of the jet keeps decreasing. Why this happens? Okay, so like this, if you observe the things, there could be a lot of things that could keep on coming onto your mind. So this is like one of the fundamental sciences. Like, to observe this, you need not be a graduate from a big college, but generally you can observe these kind of things. And also, the science of fluid mechanics got advanced to such levels that we came to the design of this fantastic structure, actually, with which we can travel kilometers and kilometers in a very less time. Okay, so fluid in general, in academic point of view, if you see generally, this is in almost all engineering disciplines like mechanical, civil, chemical, or else if you talk about bit of flow of hot metals, okay, in metallurgy and all, you have aerospace, fantastic applications again. So it got into almost all the engineering disciplines. Okay, and also the kind of research that goes on in this fluid mechanics is like pretty much an enormous research. Okay, but first, right now, in the exact at this particular point of time, we have these two things. It's a compulsory subject in many of the colleges and in many of the courses as well, and exclusively for gate examination. Because I have marked it in green color, you can see, because the main purpose of this video is to explain you how to get this 8 to 9 marks in fluid mechanics. And whatever I have mentioned here, this is not including hydraulic machines. Okay, this is exclusively for fluid mechanics. Clear? So in this video, from now onwards, we got little enough motivation. From now onwards, our main motto is how to do this for gate examination, actually, here. Okay, and now if you see this, like general opinion on topics, like for example, let us suppose किसी कॉलेज में मैंने अभी फ्लूइड मैकेनिक्स पढ़ा था. So you can see, when I teach till this particular topic, fluid and its properties, hydrostatics, I mean pressure and its measurements, hydrostatic forces, buoyancy, and also a bit of kinematics. So till here, people keep their smile on their face. They look very happy, actually. Okay, but by the moment I forward from this kinematics to the next level, then definitely they won't stop. And why these guys are running? Because you can see there's a name here. And what is that? Reynolds transport theorem. Okay, so a lot of vectors and all the things comes into picture. So people, they change their opinions and they start feeling the hecticness of the subject, actually. Okay, so that need not be there, actually. Okay, and many other topics like this, Navier-Stokes equation, when we derive the Navier-Stokes equation, or the boundary layers, and also when we talk about the potential flows in complex numbers, okay, which is very simple, of course, but generally these are the topics or the domains where people don't feel much easiness in the subject. Okay, so that's why. But actually there is no necessity of running away when you are getting afraid when you see these topics. Rather, ये topics बहुत आसान topics है, actually. Okay, so अगर आपकी concepts में visualization है तो, now let us see what should you study, actually. Okay, let us suppose if I'm going to attempt GATE or ESE or any other examination in general, so fluid mechanics से मैं किस चीज पढ़ना चाहता हूँ. Okay, so this is a broadly outcome of the syllabus. So ये complete GATE syllabus है. So इस GATE syllabus को मैंने 3 parts में दिखाया आपको. So one in green color, slightly a bit of a bit of pink plus orange shade color, and also a bit of blue color. Okay, so all these are the happy faces, and from here, as I told you, expressions change, because control volume analysis, mass, momentum, and energy, of course, and fluid acceleration, basically differential and integral analysis of fluid systems. That's it. Okay, and obviously viscosity. When viscosity comes into picture, so viscous flows, boundary layers, all the things that comes here. Okay, and there's slightly independent topic which was added 2-3 years before in 2021, basics of compressible fluid flow, and generally one question comes from this every year. Okay, so this is the syllabus that we discuss in broader sense in general. Okay, and like basically covering this syllabus is not a very big task for you guys, because you can see you can have enough time, and also majority of this syllabus do not involve much mathematics actually. Okay, it's like physically understanding and a bit of basic differentiation and integration से चलता है. Okay, लेकिन अगर कुछ टॉपिक्स में like control volume analysis of in momentum, also in angular momentum we go for the cross product of vectors, and also in viscous flows of incompressible flows, when we deriving the Navier-Stokes equation, we come across the stress tensor, basically a matrix and all. Okay, so apart from that, rest of the things it's fine actually. Now the basic point is syllabus सबके पास है, correct? अगर किसी ने गेट 2024 का वेबसाइट खोला तो उनके पास भी syllabus मिलता है, लेकिन how do I study? This is the most important thing. So you know what to study actually. This is the complete syllabus. Now how to study is the important thing. Like for example, we'll start, I'll give you a step-by-step procedure in studying fluid mechanics, and not only fluid mechanics, in general in any subject. Okay, the advantage with fluid mechanics is, let us suppose मान लो कि आपने manufacturing पढ़ा है. Okay, so it's not possible for you to see a lathe machine daily unless you go to college and workshop daily. It's not possible for you to see a lathe machine daily. मान लो कि आप हीट ट्रांसफर पढ़ रहे हैं. ओके, सो इट्स नॉट पॉसिबल फॉर यू टू सी ए हीट एक्सचेंजर डेली, बट लेकिन जब आप फ्लूइड मैकेनिक्स पढ़ते हैं, सो इट इज पॉसिबल फॉर यू टू सी फ्लूइड्स एवरी डे टू डे लाइफ. द मोमेंट यू वेक अप, washing your face, brushing, okay, moving on out, you can see a lot of fluid, and every minute you breathe in fluid and breathe out fluid. Okay, gases, oxygen, carbon dioxide, both are gases. So basically anyway, what I'm telling in mathematical point of view is actually, first of all, जो concepts होते हैं वो concepts बहुत अच्छे से पढ़ना है. Okay, so you should get each and every micro detail about the concepts. So where do you get these concepts? Basically आप classes attend होते हैं, and also in YouTube you have a lot of platforms actually, and you can you guys can enormously work out if you really wish to study. There are plenty of things like books, videos, and a lot of other stuff on internet. Okay, and once you learn the concept, you have to visualize the things. Like example, I'll tell you one example. Intentionally I have taken this glass picture because सब लोग को पता है कि Bernoulli's equation का formula क्या होता है. Okay, so P1, let me write a bit of formulas here, like P1 by OG plus V1 square by 2z plus z1 is equal to P2 by rho z plus V2 square by 2z plus z2. And honestly speaking, क्लास 12 और क्लास 11 बच्चों को भी पता है कि ये Bernoulli's इक्वेशन है, लेकिन इस इक्वेशन को कैसे अप्लाई करना है. सो दिस इज एन इंपॉर्टेंट थिंग एक्चुअली. ओके, नाउ हाउ यू गाइस गोना वर्क इट आउट? लाइक फॉर एग्जांपल, like let us suppose a normal person view this jet. He just thinks that we open the tap, water is coming, so we are filling the water in glass. लेकिन आपने अगर थोड़ा concentration से observe किया तो you can easily observe, if you take two sections here, the diameter here d1 and the diameter here d2. One thing is definitely clear to you that I think this is very bad choice of color, maybe it's not visible to you, but yeah. So you can understand one thing, D2 is less than D1. Now why D2 is less than D1? If you question this is visualization. Okay, every day you open a tap. So when you open a tap, if you ask this question to yourself, why diameter of the jet is decreasing? Or if you are walking on road, there's a pipe or there's a lawn. Okay, you are sitting in the lawn of your college. If the lawn sprinkler is rotating, then why it is rotating? If you want to stop the sprinkler without rotating, what is the torque you have to apply? So these kind of things make the visualization of the concepts what you read in the book. Okay, let us suppose if you hold a pipe, for example. Okay, if you press the end of the pipe, why fluid velocity will increase? In your garden, let us suppose you are watering your plants, for example. If you press the end of the tube slightly, then water velocity will increase. Okay, so why the water velocity increases? So when you start thinking these kind of things, you start visualizing the things. Till then only you will know this, but if you start visualizing, you will apply this. Then obviously if you apply the Bernoulli's equation and also continuity, first of all, if you apply the continuity equation, you will come to know what is the why diameter is actually decreasing. Because you can clearly see, if you apply continuity equation, A1 V1, of course I'm assuming the flow to be compressible. I'm not writing any vector notations and all, because practically if you want to write the equation, continuity equation is dou by dou t plus divergence of rho v bar is equal to 0. But right now we are not going into the toughest business. We are going into the simple business like incompressible flow and all. So if you assume that this density cancels, now obviously a1 v1 equal to a2 v2. Now for the velocity, for the jet area to decrease here, definitely velocity has to increase. What is the meaning of increase in the velocity? School boy definition, 9th class student. So if you ask why velocity is increasing, that means asking this question that why velocity is increasing is same as why the fluid is accelerating from here to here. Correct? Because obviously if there is no force acting in this direction, then definitely fluid will not accelerate. Okay, so asking that why diameter decreases is asking same like why velocity is increasing at this point, or asking same as why fluid is accelerating. Because when the moment fluid starts coming out of the tap, there is a gravitational force acting on the fluid, and obviously when there is a gravitational force, the gravitational force will pull the body faster, and obviously as the jet starts coming down, its velocity will increase, and as a result from this equation diameter will decrease. So when you see a water jet, these equations should actually roam around you. Okay, and if you can visualize these equations and all, when you open a tap, you need not open your books for a long time. You can clearly keep on going. Okay, so once you start visualizing things, then the next thing is actually getting a bit of elementary maths and equations. Visualizing is the jet is decreasing. Now why this is decreasing? It's not enough for you to study the definition of fluid and also types of fluids, nothing. You have to put some mathematics, some equations, and you have to build. So you have to follow the elementary maths and equations that gets involved. So once you get the understanding of the concept, so these are the 3 steps. Many people, they stop here. They feel that they have learned the concept, they know this equation, that's it. They leave. But no, it should continue till here. Once you is still here, then writing for semesters or gate examination, you should have the idea on how examinations are being conducted. So for that reason, you should go for the PYQs. Okay, and once you solve the PYQs, you will get in touch with the kind of subject, the kind of questions they were asking in the exams and everything. Okay, so once you solve PYQs, then definitely you can try some new questions to solve, and also you can write essays, whatever. You have different n number of sources for getting new questions, so you can start attempting those questions. So if you follow this technique for each and every subject, then definitely you're going to rock in the examination. Okay, so this is the sequence of studying. This is the sequence of studying this complete thing. Okay, so for each topic, if you do all these, for each topic, if you do all these things, then definitely you are pretty much clear about all the things. Okay, then I would like to help you with few things that how to go with these new questions and all. These are the 2 books which are very famous, and also 𝐂𝐤𝐿 and 𝐂𝐚𝐭𝐜𝐡 is like, basically it's like a novel kind of thing. If you start reading, you keep on understanding the things. You need not involve very complicated maths. But Fox and McDonald is one very excellent book, where many times, even often after teaching the subject for 6 to 7 years, even I felt like majority of the gate questions directly come from this book, like slight data change or concept slightly they change. And in gate examination or ESE, majority of the questions comes from these 2 books, and also there is one book, Frank M. White. In Frank M. White also many unsolved problems which are suitable for gate pattern kind of thing, so they come. Whenever you start solving new questions, it's like, for example, if you open Frank M. White, in the first chapter, after first chapter, you have some 101, 110, 120 questions. It's not like you keep on solving all the questions. When you start reading the question, you get the idea whether this question can be asked as a gate question or not. Why? Because you already solved PYQs, so you have the knowledge how the questions are coming and what level questions are coming. Okay, so, and obviously S.K. Somsa and 𝐵𝐻𝐻𝐿 Biswas sir, Suman Chakrabarty sir, recently Presidential Award winner. So this book is also one of the fantastic books. The unsolved questions of this book, for every unsolved question, answer is given. So after going to the first 4 steps of your knowledge, like learning the concepts, then visualizing, and then if you start putting into equations and solving PYQs, then if you start solving this book, it's like a fantastic go for gate examination and also all the technical examinations within India. Okay, so all these 4 books, like for example, 𝐂𝐤𝐿 is like one of the simplest books that you can start with maybe. Then Fox and McDonald, slightly a bit more level, and obviously Frank M. White and this are very fantastic books for problem solving. Okay, so a lot of problems are there, n number of problems. Like here also, I think this book is in essay editions. Yeah, this is in essay editions, essay units. Okay, so like this, you keep on studying for this particular subject. Okay, but this sequence, if you follow, this is the most important sequence that you should follow for any subject. So these are the books that you can study if you need, and also whenever you get a doubt, don't feel hesitant to ask us. Okay, so because we'll be with you always, and you can type in Google as well. And also since you guys are patient for this time, so that's all from my side, roughly speaking. So but since you guys are patient till this part of the video, I would like to give you some 2 questions, okay, because for free, because like I always love to share knowledge. So first question, does buoyancy force always act vertically upwards? This is one common question that many in few interviews this question actually comes out, okay. As per our understanding, generally when you take a static fluid, let us suppose if this is a static fluid, if you have a body, then we generally feel that the buoyancy always acts in the upward direction. This is buoyancy force, but actually this is a static fluid body, okay, and buoyancy obviously acts. Then the thing is, it need not be always vertically upwards, because let us suppose, I'll tell you one thing. Let us suppose if you have a container, for example, and this container is moving with acceleration ax, okay, then we all know that the level of free surface of water will take a dip like this, correct? So this will be the free surface. This will be the free surface actually here. Now, if this is free surface, that means, can I say this is also the line of constant pressure, correct? So constant pressure, which means one thing is very clear, that all your lines of constant pressure will be like this, inclined. Now, let us suppose if you tie a balloon, for example, okay, balloon is one small body like on which the buoyancy acts. Initially, the balloon is supposed to be like this. Look, we'll try to make an attempt to draw this nice diagram. So, yeah, let us suppose if the balloon is initially like this. This is the initial configuration. It is tied to a thread. But once the tank starts accelerating and the fluid, which is initially horizontal, took a tilt, this balloon will have this orientation. So this is the new configuration of the balloon. The reason being, you can understand one thing. If you move from right towards left, obviously the pressure increases because the height of the fluid column increases. You know, from hydrostatics, dou P by dou Z is equal to minus rho g. So as let us suppose if you take 2 points on the same horizontal level, for example 1 and 2, obviously pressure at 2 is more than 1, but the lines of constant pressure are like this, so the buoyancy always acts perpendicular to the lines of constant pressure. So these are the lines, so the direction perpendicular to these lines is, this is 90 roughly. So buoyancy always acts perpendicular to the lines of constant pressure. In this case, since your lines of constant pressure are horizontal, that's why buoyancy is vertical, but here your lines of constant pressure are not horizontal, so your buoyancy need not be vertical, obviously, okay. So this is one very important point, so please keep in mind, just as a gift, okay, because today is engineers day as well. So second, why Reynolds number flows are turbulent in nature? Okay, so Reynolds number, we know that it is inertia forces by viscous forces, okay. Now basically, what is inertia force? You know, from Newton's first law of motion, generally when a body is moving, then it tries to move unless objected by some external effect. And what about the viscous force? Tries to stop the flow. You guys know this, okay. I'm not going into much details formula wise, this is just a basic introduction kind of thing. Now you all might have experienced this whenever you are going on a bike, for example, okay. If you are going at a speed of some 30 kilometers per hour, let us say, and if you apply brakes to the bike, what happens? You guys stop smoothly, correct? But let us suppose you are going at 120 speed, and if you apply brakes, what happens? Obviously your bike starts shaking, correct? Basically you won't stop in a smooth way, you will actually stop in some zigzag way. Same is the case here. Whenever flow happens, when inertia force is very high, if F inertia is very high, then what happens? Even though your viscous force is trying to stop the flow, but still because of high inertia or high density fluids generally, so because of this high inertia, the particles keep moving, so that's why it's like having a bumpy road, okay. So that's why the fluid actually goes at very zigzag pattern actually, okay. So it's something similar to your mechanics point of view, obviously. And when inertia forces are high, then definitely these viscous forces, even though they are present, they are not able to stop the flow effectively, so it tries to continue the flow. Like the case of your bike, this fluid will actually experience some zigzag path, okay. And of course, if you try to convert this to inertia forces as rho v square L square, all this stuff, then you will get rho v d by mu and all, okay. But of course d is not always the diameter, because let us suppose if I give you some square pipe, for square pipe you cannot define a diameter, unfortunately, okay. So actual formula is rho v average hydraulic diameter by mu actually, okay. So this is the formula, and hydraulic diameter is actually 4 times of area of cross section of flow divided by wetted perimeter. Wetted perimeter actually. Okay, so this is the hydraulic diameter basically. Okay, and what is the wetted perimeter? Normally in case of pipes, what happen? Whenever a pipe, let us suppose if this guy is a pipe, if fluid is completely flowing inside it, okay, means if you see, for example, this is the cross section of a pipe and fluid is completely flowing in this pipe, then definitely what's happening, the perimeter completely is being wet by the fluid. So definitely dH is equal to 4 times of pi by 4 d square, area of cross section of the flow, divided by this fluid is wetting the complete perimeter. So this is pi d, 4 pi d, and this square gets cancelled. So you have one more d which is left. So dH is equal to d obviously here. Okay, so that's how you use d in the formula for pipe. But if it is a square, rectangle, whatever, now you can use this formula to calculate the Reynolds number. Okay, but the main reasoning is when inertia is predominant, the fluid, even though viscous effect is trying to stop, the fluid still try to maintain the flow. So there comes an imbalance, like the case of your bike applied brakes at high speed. Okay, so these are the two small important things that I thought of telling you because you are till the end of this video. Okay, and definitely, yeah, I think one important slide also for you. Thank you. That's it. Okay, so and if you want to get in touch with me in personal, if you feel that I can help you out somewhere in your journey, you can always try to reach me at this is my Telegram channel, ID. Basically, it's managed by majority of the students of mine and also me. Okay, this is like a basically a going to the kind of group. Like if you have some doubt, you post it there. Some of your friends will answer it for you. If they cannot answer, definitely I'll try to post my view on that. Okay, so and during your admissions or at any point, if you need any, if you feel that I can help you out, you can definitely reach me out in this ID. Thank you all. Okay, I hope you got some enough idea and use out of this particular video. And once again, if you quickly want me to go to the things, so I'm giving you a insight like the weightage of this particular thing, and also the like basic the syllabus, and also how to study, and also from where to study I have given you. Okay, and these are the details of this course, because in the beginning of the thumbnail I have kept some 3 topics like top weightage, PYQs, and complete detail. I think so. I think this video made enough justice. Thank you all. Take care.